In this video, I'm going to show you how to answer certain questions about a rectilinear motion when the position function is given. So in this problem, we have a falling object, and every falling object has its position function given by equation like this. So the first question is how far it has traveled 5 seconds after being dropped. So using function notation, we interpret this question as to find the output when the input is 5. So we simply have to evaluate this function at t equals 5. So the answer is 122.5, and the units are meters. So the object has traveled 122.5 meters. So the next question is how fast it is traveling 5 seconds after being dropped. So we interpret this question as if we had to find the velocity at time equals 5 seconds. From what we know about rectilinear motion is velocity can be found by differentiating the position function. So we have to find the derivative of a position function first, which is this, and we have to evaluate it at t equals 5. So this is 49, and the units for velocity are meters per second. So how fast it is traveling 5 seconds after? The answer is 49 meters per second. The next question is to find the acceleration after 5 seconds. We interpret this question as to find the acceleration when t equals 5. We know that acceleration is the velocity, the first derivative of the velocity or the second derivative of the position function. So to find it, we have to find the derivative of the velocity, which is just 9.8. So what does this mean? That means the acceleration of the fallen object is 9.8 meters per second squared, and it doesn't depend on time. And this is a well-known fact in physics. This is a constant, acceleration constant, which is equal to 9.8 meters per second squared.